Number 4. All right. Yeah, all right. Yeah. Number 4. Let me say something. Yeah, the hints. All right. 7-element array with only one inversion. Okay? You know the meaning of inversion, right? Yeah, invert. So then, I give you the specific order of these elements. The elements you can see, if we swap F3, F4, and F5, then they're ordered, right? So one swap, you get the whole array ordered. That difference. So the question is, now we apply our insertion sort, our current standard insertion sort, okay? You know how to run the insertion sort, right? Yeah. Yeah. So you apply insertion sort step by step, okay? Element by element, you count the number of comparisons. Can you do that? Yeah. You count the number of, all right. So this is your, you know, because given the order in this way, when you do comparison, you know where to stop, right? Yeah? When you insert new element, do you know where to stop? Right? Yeah. All right. Let me just, you know, give you some information like this. Okay, all right. All right. When you insert x2 into the currently ordered array, how many comparisons? 1. All right. So after 1, you get x1, x2. Then x3, you insert it. Based on the information here, how many comparisons do you need? I cannot tell you anything. You make your decision, right? Yeah, in my hand, because I cannot tell you the answer. All right. After that, 1, 2, 3, x4. How many comparisons? Get it ordered. Yeah. Right? Then continue. Yeah. After 1, 2, 3, 4, this time x5. Now, you know, look at the specific, you know, one comparison. Do you need to do another comparison? Right? Based on the information given here, you make your decision. Number of comparisons. Number of comparisons for each insertion. Each insertion. Okay? Yeah. From beginning to end. That's the, you know, yeah.
The first step would be x5 instead of x4. That's the next element to the array.
Third step. Oh, but when you work, so this is the, you know, order info, but when you do the work, you still process x1, then x2, x3. You follow this order for your data processing, okay? This is not the order for the processing, okay? That's the underlying order, okay? Yeah. So that's the, you know, real input, the real input situation, okay? But when you do the process, because your algorithm does not know anything, right? For any data given array, you run the same algorithm, right? So your algorithm is blind. Your algorithm always works the same way for any given data. So the same way, what is process x1 first, x2 second, x3 next, in this natural order, okay? So this is not the, you know, when you do insertion, not in this order, okay? Yeah. 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 That's this question. Yeah. Next one.
I have a question. So question number 3, we did not use the special dynamic method that you showed during the underclass. We're using the regular insertion sort, right? For question number 3?
Yeah, regular, the standard. Yeah, do not use the binary search way. Okay. You have to use the, you know, from right to left, that order. Yeah. So we have some faster way. Yeah. Because we do the binary search type comparison. No, because the reason binary search type, why the binary search type we can do it when we do that binary search type. Usually the number of elements relatively small, so we do not need to do shift, okay? Yeah. But for a long array, you have to do the shift operation. Otherwise, so where do you place your elements, right? Yeah. So that's different. So when you work on an arbitrary array, you cannot use that binary search type. Yeah. Because binary search, you cannot find the storage location. Where to find the storage location, right? It's hard. Yeah. All right? Yeah. But if you need to make some room there, your binary search, although you do comparison fast, but when you do the shift, you go back to the linear, right? Yeah? You go back to the linear. Yeah. Yeah. All right. Yeah. So, other questions? Feel all right? Yeah. Other questions? Yeah. Try to think about it. Anyone is okay with question number 10? This recurrence relation, derive the recurrence relation for this function, derive recurrence relation, then apply that relation to find this expression. Yeah. All right. It's an integer, so we do not want to plug in. Okay. Yeah, we do not want to plug in. So we want to derive some recurrence relation. Yeah. All right. Yeah. All right. So let me explain. Yeah, because one student from online class asked me this question. Yeah. So if you do not ask, so here I explain for that online student. Okay. Yeah. All right. So here you need to use a special algebraic property in this question. Yeah. You need to connect it to a special algebraic property. If you cannot see that, then it's hard. Okay? All right. So what's that special algebraic property? Look at this special multiplication. Oh, all right. So this is Sn, right? Yeah. Then let me multiply another. This is S1, right? Yeah, 1. Now let's look at this. What is the multiplication? Multiply through. Let's see. Yeah, what do we get? Phi to the 2n plus 2, right? One term like that. Then another term, yeah, because multiplication of these two fractions, we have 1 over phi to the 2n plus 2, right? Yeah. Then phi to n multiply this number. Okay? Yeah. That is phi to the 2n minus 2, right? Yeah. Then, the last term, phi to the 2n minus 2. Okay, all right. After you get this expansion, what is this? What is the expression if we use s m plus 1, right? X plus 1. What is this? S m minus 1, right? Now you get Sn times S1 equals Sm plus 1 plus Sm minus 1. Is it close to the recursive formula? Right? Recursive because we need to write the one with the largest subscript, right? We need to write the one with the largest subscript. S1 minus this one, recursive formula. But what is S1? Can you find the specific number for S1? Specific number for S1? S1 equals phi squared plus 1 over phi squared. For the golden ratio, we have two properties. One property, phi squared equals phi plus 1. Another property, 1 equals phi squared minus phi. Two properties. All right. Then, can you replace phi squared by phi plus 1? Can you replace 1 by phi squared minus phi? Okay? Yeah. Then, can you, simplification, 2 plus phi minus 1 over phi, right? All right, yeah. Do we have a little more room? Yeah, all right. Then, can you replace 1? Yeah, all right. Can you replace 1 by phi squared minus phi over then phi? Okay, second property. Simplification. 2 plus phi minus phi minus 1, right? Yeah. Cancel out. Phi minus phi cancel out. Minus 1 plus 1. You get 3. Okay? S1 equals 3. So you replace S1 by 3. That is a recurrence relation. With this recurrence, can you find S10? Oh, sorry, S5. This is S5, right? S5. Yeah. S0, you have S0, right? S0 is 2, right? 1 plus 1, 2. S0 is 2. S1 is 3. Can you get S2 from this formula? After you get S2, can you get S3? After you get 3, can you get S4? Then S5. Okay? Yeah. That's how to solve this question. And remember, the word solution here, you need to write details. Okay? Yeah. So when you have answers, then you do not have to write the details, but when you write the main steps, you can earn partial credit. Yeah. Even if your answer is incorrect, you can earn partial credit. Okay? Yeah. But when you see the solutions, then you have to write the whole solution. Yeah. The complete solution. Okay? Yeah. That's the difference. Okay? Yeah. Yeah. I saw many students, yeah, mainly from the online class. Yeah. Many of them, they only give me one number. Okay? One number, then the risk is pretty high, right? Hit or miss. Okay? When you miss it, you have no chance to earn partial credit. That's the risk. Okay? All right. Next question.
We had can we look at that
Number 9. Yeah, all right. Number 9. Yeah. This number 9, you need to have the make connection to our existing question. Make connection to our existing question. If you are not familiar with our existing question, then it's hard. Okay? Yeah? So connect to, so the first instruction, connect it to one of our examples. Yeah. Or, so because I gave you before. Oh, what's that? All right. Oh, why I cannot remove? Yeah, the software, not that. Yeah. Anyway, one of the old examples. Okay. All right. Bottom 2. All right. So let me draw a diagram. Relatively large number of elements. Yeah. So this number is some kind of, not very important. Okay. So this number is not very important. Yeah. Kirill?
But we can choose 5, like
Yes.
elements.
Good. 5. Yeah. Because we have experience before. Yeah. If you tell me 5, then I know you you have that part. You have the first critical step. Remember, we did one old question before. Neither minimum nor maximum, right? Yeah. So not a minimum, not the maximum. Then we need to choose some between. Then we choose 3 elements, right? Yeah. Yeah. So we have that old example. But now, similar situation. Yeah. It cannot be the bottom 2. Okay. Cannot be the top 2. Then we only need to choose 5 elements. Okay? Yeah. 5 elements. When you choose arbitrary 5 elements, can you find the median? Median of 5. Do we have an example how to find median of 5? Do you remember we have an example how to find a median of 5? So, example. Okay? We have that example. How to find the median of 5 elements. Okay? Yeah. Module 4, part B. Sorry, yeah, part B. Yeah. Part B, remember binary search and the selection problem, right? Binary search, selection problem. at the end of that lecture, end of part B, the last example I did, find the median of 5, okay? Yeah. You know, I did in that annotation, okay? Annotation, you know, you can find. Yeah. How to find median of 5, okay? Yeah. All right. Other questions? Other questions? Feel all right? Other questions? Or later questions?
Oh yeah, I have one question. For number 8, when we do the merge sort binary tree, and we have 5 pairs,
Yes.
do
Oh.
we combine the 1 pair with the 4 element afterwards? The merge sort, we have to separate into each element and then merge those, and then continue merging.
Yeah.
Or
Yeah.
what do we do if we have an even number of
Yeah, yes.
arrays?
All right, let me answer in this way. Okay, yeah. Yeah, I noticed, you know, many students use slightly different way. So here we need to look at the standard merge sort, okay? So when we split, we always split based on the median to do the split, okay? All right, so here, let me draw. Yeah. These 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, yeah. All right. Then the first split, this, yeah, because many students, they, you know, based on last semester, they do pairing, okay? So many students, you know, do 5 pairs. If you do this way, that it's different from the standard, yeah, standard merge sort. So we do not do pairs like that. Then you merge, you know, like that. Okay, so that's not our standard way. Okay, so our standard way, yeah. When we do divide and conquer, we always divide based on the median. The first divide. So this is the first. Yeah. Then you split two subarrays, 5 elements each. Okay, all right. Then second. Yeah, because 3 is the median. So median, we put it in the left subarray. So second. Second round. Split. Third split. Third split. Here. Third split. Third split. Third split. Okay, all right. Then the last split, fourth split. Then fourth split. Okay, yeah. So you split all to singleton. Yeah. All subfiles are singleton. All right. Then when you do the merge, you reverse the split order. Okay. First, merge 2 subfiles corresponding to the fourth split. 1 merge. Okay. Yeah. Then 1 merge based on the 4th round split. Reverse order. Okay. All right. So do not touch the next round. After you combine. Then next merge, reverse that third round split. Okay, yeah. And third round split. I think third round split covering these 3 elements, right? Yeah. Here, these 2 elements. Yeah. Here, these 3 elements. Okay, third round, these 3 elements. Okay, yeah. Thanks. Then round 2, recover. Round 2 split, yeah. Merge these 5 elements. Merge these 5 elements. Okay, then the last merge, or reverse the first round split. Yeah. So when you do the merge sort using this way, round by round. So round by round, when you do split, okay? Yeah. All right. So try to keep track of your split. Okay. Then go in that reverse way. Yeah. Merge. Yeah. Yeah. Reverse the path. Okay. Yeah. Backward. Yeah. 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 For the split, it doesn't matter worst case, best case. So for any case, we do split like this. But the worst case, best case, the difference is when you do comparison, the comparison result is different. Okay? All right, let me tell you. All right. So here, this example, descending order, so it may not be worst case, best case. Okay? Yeah. So here, I can explain the worst case and the best case. All right. The split, same split, but when we run worst case, best case, the result is different. Yeah, let me show you the worst case, best case. Yeah, let me run it. Okay. All right. So let me do the best case here. Best case here and the worst case here. Okay. Worst case here, separately. Okay. All right. Best case, we know the formula is minimum of mn. Minimum of m and n. This formula. Okay. When we merge. Worst case, we know the formula is m plus n minus 1. The formula. We apply different formula when we do the merge. All right. Then, the first merge corresponding to round number 4, 1, 1, right? mn. Yeah. Because, yeah. So here, m is 1, n is 1 by the best case formula, minimum of 1. It's 1, right? Yeah. So the best case, so here, round number 4, fourth. Yeah. So corresponding to 4th. Okay. All right. So the first merge, 1, 1, we take the minimum 1. Yeah. So here I use this special notation. Merge result. Merge result, the first merge, minimum of 1, 1 is 1, right? Yeah, 1. Yeah. Then I use a vertical bar to separate. Because after the merge, there are 2 elements, right? So I put that number of elements. Because I need to use this number later. So that's why I need to store the number of elements after the merge. So 1, that vertical bar, 2. 1 tells me number of comparisons. 2 tells me the number of elements in the merged array. Yeah. So, all right. So that's the first one. Okay. Then we have another one. 1 vertical bar 2. Okay. So for these 2 merges, 4th corresponding to the 4th rounds. That third round. Also, that's the best case. Third round. This time we merge 2 and a 1, right? Yeah, because this time we merge 2. Yeah, this time we use that 2. Okay, and element 1. Okay, 2 and 1 you apply minimum of 2 and 1 is 1, right? Yeah. So that you have 1 vertical bar, yeah, because minimum. Number of total elements in merged array 3, right? Yeah, so 1 vertical bar 3. Okay, all right, so that's this one. That one, 1, 2, right? Yeah, because that one total number of elements 2. Yeah. 1 vertical bar 2. Okay, yeah, so this one, that one. Yeah. Then this, so 2 and 1, yeah, so that's 1, 3, another 1, 3, right? Yeah. Then 1 and 2, 1 and 2. So that's the corresponding to the third round, that formula. Right. Then, second, this time we need to merge element 3 and 2 to merge. 3 and 2, minimum 2, right? Yeah. Minimum is 2. Vertical bar, the sum of these two numbers, 5. Okay, 5. Then 3 and 2, minimum 2, total number 5. So the second run is these numbers. All right. Then the first run, yeah. This time 5 and 5. Okay, yeah. The minimum of these two numbers 5. Total number 10. Okay? Now, let's calculate total number comparisons. This round, subtotal 1 plus 1, 2. This round, 1 plus 1 plus 1 plus 1 equals 4. Okay? Yeah. You use the number before the vertical bar. Okay? So sometimes you use the number after vertical bar. Sometimes you use the number before the vertical bar. Right? All right. So this round, 2 plus 2 equals 4. Yeah. This one, you get a 5. Okay? Now the total, you add, yeah, round 4, you have 2, right? Round 4, you have 2. Round 3, you have 4. Round second, you have 4, and the last round you have 5, right? Yeah. You know, yeah. What's that? 15, right? Yeah. Worst case. Okay. All right. Sorry. Best case. Yeah. Let's do worst case. Yeah. Worst case, same thing, but our number will, change. Same kind of merge, but the formula, you just change the formula. Okay, all right. Fourth, okay. Yeah. So 1, 1, 1, 1, 1 plus 1, 2, 2 minus 1. So you also have 1. Okay. Yeah. The first number is 1. The total number of elements 2. Okay. All right. So 1, 2. Yeah. The same as the best case. Yeah. But later number will be different. Third. Okay. Third, 2 and 1, right? You merge 2 and 1. 2 and 1, 3, then 3 minus 1, right? M plus N minus 1. You use this formula. M plus N minus 1. M plus N, that's 3. 3 minus 1. So you get 2 vertical bar 3. Okay? Yeah. Then merge these two. 2 minus 1. So still 1 vertical bar 2. Okay? The next, 2 vertical bar 3. 1 vertical bar 2. That's the third round. Second. All right. Now you merge 3 and 2, right? 3 and 2. 3 plus 2, 5. 5 minus 1 is 4. So you have 4 vertical bar 5. Next one, also 3 and 2, 5. 5 minus 1, 4. So 4 vertical bar 5. Okay, all right. Then the first round. First round, work on the 5 and the 5. 5 plus 5, 10. 10 minus 1 is 9. 9 vertical bar 10. Okay? Yeah. All right. So subtotal, fourth, subtotal 2, right? Fourth, subtotal 2. Third, 2, 1, 2, 1, 6, right? 6. 4, 4, 8. This 9. Okay. This 9. Okay? So the total for the worst case, 2 plus 6 plus 8 plus 9, 8, 8, 16, 25. Worst case, 25. Best case, 15. Okay? Then, this descending order, somewhere between, okay? Yeah. Best case, worst case, I don't know, okay? Best case, worst case, you need to look at the data. When you do the merge, each merge, you need to use our standard merge operation to see what's that number. Because this time there is no formula. You need to look at the specific merge operation. Okay? So in our previous 2 examples, you can use the formula. Okay? So here, these 2 formulas, you should use one for question number 6. That's the best case, right? So that's the best case you use on this question number 6. The worst case, that one example, yeah, you use for question number 7. Worst case. Okay? All right. Then, when you work on question 8, descending order, then there is no formula. There is no formula. So, or you can, if you want, you can derive the formula. Yeah, it's possible, you derive the formula. Okay? Yeah, if you want, yeah, because based on your study, you can discover the formula. Okay? If you discover formula, you need to use a new formula. Combination, same way combination. Split, combination, the same way. But your formula is different. Randy, the formula is different for question number 8. Okay? The formula is not too hard to discover, right? Descending order, is it hard to discover? Yeah? No. Descending order, right? Descending order. So, not that hard. Okay? Yeah. Okay. All right. So, 3 questions we covered. Yeah. Using this example, we covered 3 questions. Yeah. Yeah. Other examples. Yeah. So pretty much the first half we complete. Yeah. Let me look at the time. Yeah. If we have enough time. Yeah. Yeah. We still have quite some time. Yeah. Some more questions. All right, yeah, okay, number 14. Number 14. Yeah. This many elements. Then array that is neither the minimum, yeah, so neither the minimum, okay, yeah, not the minimum, okay, all right. Yeah, because based on our diagram, at the bottom, we should have at least one element below the right one. So here, we are working with, we need to find the right one. That right one should be at least above one element at the bottom. Okay? All right. Then, no in top 19. No in top 19. Yeah? So above that element, we need at least 19 element. Okay? So we need to have at least 19 element above that right one, okay? That right one. So suppose this is the right one, okay? Below at least 19 elements. above at least one element. Okay? That's one. Okay? All right. So from this diagram, you can see there are so here, the elements involved in this diagram, 21, right? 19 plus 2, 21. Okay? In these 21 elements, the targeting one, so this is the target. The targeting one is the second smallest, right? Second smallest. Do we have the formula to find the second smallest element? We did an example, right? Yeah. So I told you at that time, so that formula will be used in one of the homework assignment 2B questions. This is the one. We have the formula in our notes. Okay? Yeah. So you, yeah.
Professor, can you approximately tell where was that formula?
Where was that formula? Let me see. Heap sort? Or, yeah, as I remember, heap sort, yeah, the first class heap sort, okay? A1, yeah, because part A we did, yeah, let me see, part A, oh, sorry, yeah, part A we did 2, and yeah, as I remember, A1, module 5, part A1, yeah, so go, module 5, part A1. We have A1, A2. A1, yeah. Let me double check. Okay. Yeah. Let me double check. Yeah. So, because my memory may not be reliable. Yeah. Yeah. Just let me use 2 minutes to find it. Yeah. If not A1, it should be A2. Yeah. A1 or A2. Yeah. Okay. A1 or A2. So that A1, let me see, A1, A2. Okay. Yeah. All right. Yeah. See? This one. Okay. I don't know if it's this A1 or A2. Oh, A2. Yeah. This one actually A2. Yeah. Because A1 I only do introduction, right? Yeah. I didn't do the the heap part. I do introduction. So A2. Yeah. So yeah. Can you see here? 8.5. Find the second largest, smallest, the same formula, right? Yeah. Yeah. Then the details, yeah, here. Oh, yeah. The first slide, that's a homework, that's the midterm question. Yeah. So you look at the second slide. This slide, HW2B, remember the formula at this bottom, okay? Find the total, this bottom right bottom corner, okay? Yeah. Corner, okay? Yeah. That formula, that's the formula, all right? Okay? That's the formula. You know that n, right? Yeah, that 21, so that, not 19, yeah, 21, that's the n. Yeah. Okay. All right. Yeah, so let me go back to change. It's not A1, it should be A2. Yeah. A2. Okay? Yeah. All right. Yeah. More questions you can ask. this number 15 is the hardest one. This is the most challenging one. So I give it to you. Yeah, let me say something, okay? Although you do not ask me, but because this one is very hard, so I want to say something, give you some related information. You can try your best, okay? Based on your answers, I give you different number of points, okay? Yeah, the better you do, the more points you get. Yeah. So let me tell you. So I give you 3 options for question number 15. Yeah. 7-element array with distinct elements. Yeah. What is the minimum number of comparisons you need to find the median of this array? 7. Yeah. All right. Okay, the median. Total 7. All right, so we need to find the median one. Okay, all right. 1, yeah, because when we work on, so this question, very hard. So very hard, yeah. If you start from scratch, it's very hard, right? Yeah, if you start from scratch, very hard, yeah. But we have a lot of experience, right? We have a lot of experience. We do not start from scratch, okay? Yeah, so we build up our experience. We have quite some experience we can use. Yeah. So what's the related experience? Oh, sorry. Yeah. The experience we need to experience. We need to use. Find the median of 5. Five elements. We have that experience, right? Median of 5. Yeah. So let me find the reference. Yeah. The reference.
Module 4, section B4.
Yes. Yeah, exactly. Yeah. Module, yeah. So let me show you. Yeah. Show you module 4, part B. Yeah. Okay. All right. Part B. Yeah. Look at here. Okay. Yeah. At the bottom, last page. Okay. Page 10. Find the median of a 5-element array. Okay. Yeah. So, the diagram. Here pretty messy. Yeah. But in the video I explain. Okay. Yeah. So if you look at this slide, then you may not get it. Yeah. But if you follow the video, so you know how to solve it. Yeah. But here you can use the result, right? So we have the result here, right? You do not have to repeat. So here you do not have to repeat. Yeah. In this question, you can assume we have the algorithm to find a median of 5 elements with the number. Did I say the number of comparisons here? Here you can see 6, right? Yeah, the largest number, 6. But not 7. Why not 7? Because with 7 comparison, we can sort 5-element array. Find the median, we do not need to sort it, right? So we should do better than 7. Okay? So the best we can do, 6 comparisons. Yeah, here, the solution, 6 comparisons. All right. Now, when you get here, you can assume you already have the algorithm to find this with 6 comparisons. All right. All right. After that, yeah, because after that, there are two elements. So here, the median, so here, median of 5. So this one here, median of 5. That means there are two elements higher than this one. Two elements, okay? You know what are those two elements, but you may not know which one higher, which one lower, okay? So here, two elements higher than that, okay? So one higher here, another higher here, but these two, you do not know which one higher, which one lower, okay? Based on our algorithm, okay? Our algorithm, we got one in top 2, then we remove it. Because if it's in top 2, it cannot be the median, we remove it. If in top 2, you know, is it the largest one or second one? You don't know if it's largest one or second largest one, right? So here, when you find the median of 5, you cannot assume which one is largest, second one. You just know there are two elements larger than this one, right? Similarly, the smaller side, two elements smaller than this one, but you do not know which one smaller, which one higher, okay? Yeah, but then one in the middle. Right? Then, other than these 5, you have two more elements, right? Yeah, two more elements, now you need to continue the remaining work, okay? Two elements you may like to compare with, median of 5, right? But when you consider median of 5, you need to assume the worst case, right? Yeah. Because if one smaller than one larger, it's the best case. You completed. So you should assume these two elements at one side of this median of 5. At one side. Either the smaller side or the larger side, but because symmetric, you assume one of the two sides. It's symmetric, okay? So you can assume at one side. After that, then you are very close to the destination, right? Yeah. Not too much work. Very close to the destination. Yeah. This is the way based on our old experience. Yeah. I do not say this is the best way. Yeah. This should be a pretty good way. This way, pretty good. Yeah. If you want to beat this solution, yeah, it's possible. It should be very hard. Yeah. If you really want to beat this solution, yeah, although it's possible, but it's extremely hard. Okay. First, you need to get this solution. Okay. Yeah. If you can beat, so let me say in this way. If you get this solution, you get a full credit. 4 points, full credit. But if you can beat the solution, do one better than this one, 2 bonus points. You get 6 points, 2 bonus points, because it's very hard. I don't know if it's possible. Yeah, you can try a little bit, okay? Yeah, if it's too hard, then give up, okay? Yeah, because I myself, I do not know how to beat it. I do not know how to beat it. Okay? Yeah. Okay? Yeah. So it's an open question. Yeah, still open question. Okay? Yeah. All right. Yeah. But you may have some brilliant idea. Yeah, you can try. Okay? Yeah. But do not spend too much time. Okay? Yeah. Yeah, do not spend too much time. Yeah. Yeah. All right, other questions? We have 10 minutes, okay? Yeah. So if you like, we can still do some more. Yeah, all right, number 11. Yeah, binary search number 11. Yeah, here, pay attention to the sentence inside the parenthesis, yeah, because many students, here I want to explain, yeah, yeah. for this question, first your understanding should be right. All right. Yeah. So we have a 30 element ordered array, yeah, and the information we are given, yeah, the search key, the given key is between these two elements inclusive, okay, all right. But this information is hidden, okay? So in my parentheses, I said this information, because at the runtime, if you complete processing this array, you do statistics, you can see the result. That's the fact after we complete processing. But before we work on it, how do we know it? We don't know, right? Before we work on it, you do not know it, right? Yeah, before you work on it, okay? But after we complete it, oh, it has this property. That means in your algorithm, you cannot assume this condition, okay? When you run your binary search, you cannot make assumption, oh, I know the search key is between, you know. You cannot assume that. That's the fact, okay? The hidden fact. The hidden fact, but when you calculate the average, the hidden fact will impact the answer, right? Yeah. Your answer is based on this hidden fact. Yeah.
So you need to use the average efficiency formula and substitute for n something different than 30 elements, right?
Right. So when you do the average, yeah. So you need to, sorry, not 30 point. Still this one. But when you draw the binary tree, you need to use all 30 elements. Okay? You draw the whole tree, whole binary tree with 30 elements. Yeah. Because some students, they draw the binary tree, only use the elements between 7th element and the 26th, smaller binary tree. Then you make your assumption, right? Because when you draw your binary tree, you cannot make any assumption. Okay? Then you need to look at, the top level. Yeah. After you draw the binary tree, then when you calculate average case, you can remove the, the first 6 elements, right? Yeah. Yeah. Because the left-hand side, you can remove, 6 elements from the left end. Right end, how many? 30 minus 26, 4, right? 7, 8, 9, 10. 7, 8, 9, 10. Yeah. Yeah. So 4 elements at the right-hand side you can remove. Yeah. All right. But these nodes, although you remove, but they are in the binary tree. But when you calculate the average, you do not look at these cases. Okay? Yeah. For the average case, you only do the average on this part. Do average. Okay? When you do the average on that part. Yeah, because you never hit this part, you never hit that part. You do not need to count them, right? Yeah. Yeah. But the tree, you still, because you do not know, right? Yeah, the tree, you do not know, so you have to draw the whole tree. Yeah, that's the question. Yeah. Binary
tree, if I remember correctly, you need to find the medium and then split it.
Yes, the median. Okay, yeah. At the root, that's the median. You will know the left median, right? We assume the left median. We put a root. Then 2 subtrees. Okay, 2 subtrees. So each subtree, when you select the top node, still the median. Okay, the median of the subarray, median left subarray, median of the right subarray. Keep doing split like that. Yeah, keep doing like that.
And if we have the even number of elements, we choose the left.
Left median. Yeah, even left median. Okay. Yeah, our assumption. Yeah, default left median. Okay. All right? Yeah. So that's all you need. Yeah. Then, last a few minutes, I need to talk about two questions. The merge, related to the merge three element, right? Three arrays, right? Merge. Yeah. Let me explain that. Yeah. Because based on my experience, many students have questions on these two questions, number 12, number 13. Yeah. All right. Number 12, for the best case, you need to use this minimum formula, right? Minimum of Mn. Mn. For the worst case, you need to use this m plus m minus 1. Okay? M plus n minus 1 formula. All right. Yeah. But then, three-ordered array, yeah, so let's say A, B, C. Okay? Yeah, three ordered. You have different ways to merge, right? Yeah. Because the first way merge A and B. Okay? Yeah. Then after that, you have one way, all right? Then you have another way, C, B and C. Okay? Then A. Another one, right? Yeah. Then you have another way, A, C, B, A and C first. Then that. So you have three different ways to merge. Yeah. Three different ways to merge. We do not know which one is better, right? So you calculate. So you use the, this formula, calculate for all three cases. Okay? Yeah. Then you select which number's smaller, the smallest one, that's the best solution. That's the best solution. Okay? All right. Yeah. Then, when we get to this one, can you do the same thing? Still, those three ways, right? But you use the different formula. Use this formula. Yeah. Then, can you calculate the three numbers? Because you have three cases. You apply this formula, three numbers. After you get three numbers, do you pick the smallest one or largest one? Okay? Yeah. So this formula on the above three cases. Yeah. So then you get three numbers. Okay? Three numbers. The question is, do you select smallest number or largest number as your answer? Which one you want to select as your answer? Smallest number, because three cases, you have three different solution numbers. Do you want to use the smallest one as your solution or largest one as your solution? Why largest?
Because we are trying to find the worst case.
Yeah. But for three cases, we all apply the worst case formula. All three cases, we apply the worst case formula. Does it mean that's the worst case? Right? Yeah. So answer, select the smallest number. Do not select the largest number. Because we calculate for the three cases, we all use the worst case formula. We already consider the worst case. Yeah. So the three numbers telling you three different solutions, the smallest number gives you the best solution, the largest number gives you the worst solution. Why you select the worst solution, not the best solution, right? We consider the worst case, but we still want the best solution, right? We want the best solution for the worst case. We don't want the worst solution for the worst case, right? So what's that? Let me write it clearly. Yeah. Because the reason is when I did the grading, many students give me the largest number. Okay? Yeah. So we want to find the best solution for the worst case. Okay? Not the worst solution. Not the worst solution. For the worst case. So you know the difference, right? Not the worst for the worst solution for the worst case. You know the difference, right? Worst, the word, this word, worst case. But you use this worst at the wrong place, right? Yeah, you pick the worst solution. Yeah. Everybody wants a best solution, right? Yeah. Although we consider worst case, but we still want the best solution. Okay? We want to get the best solution. Nobody wants to get the worst solution, right? Yeah. Okay? That's the difference. Yeah. All right.